We're going to start number 12 by completing the square underneath the square root. So let's do that. And let's factor out a minus. So here we have x squared plus 4x minus 12, just getting ready to complete the square. And now let's complete this square. We're going to add 4 and subtract 4. Okay, so here we have, that's x plus 2 squared. And here we have minus 16. And now let's just multiply that through by that negative, and that switches the order, and we have 16 minus x plus 2 squared. This is of the form a squared minus u squared. So we have an a squared minus u squared under the square root, and so we're going to do this substitution, u equal a sine theta. Or in our case, we have x plus 2 equal 4 sine theta. And dx is equal to 4 cos theta. So let's do that substitution. And we have 16 minus, and now we're going to square this, 16 sine squared theta times 4 cos theta d theta. In parentheses, we have 16 1 minus sine squared theta, which is 16 cos squared theta. Alright, so if we take that out of the square root, we have 4 cos theta times 4 cos theta. Okay, so that's equal to 16 cos squared theta d theta, and we're going to use a trig substitution to evaluate this. Okay, cos squared theta is 1 plus cos 2 theta over 2. Now let's integrate. The integral of 1 is theta. The integral of cos 2 theta is 1/2 sine 2 theta. Alright, now we want to substitute back. Let's remember we had x plus 2 is equal to 4 sine theta. Okay, so that means x plus 2 over 4 is equal to sine theta. And we draw a little triangle. Opposite, hypotenuse. This third side is 16 minus x plus 2 squared. Here we have sine 2 theta. We can figure out from this triangle trig values of theta, so we're going to do another trig substitution. Sine 2 theta is equal to 2 sine theta cos theta. Alright, so here we have 16 over 2, that's 8. Theta plus sine theta cos theta. And now we're ready to substitute in. So theta is arc sine x plus 2 over 4. And then we have sine theta, cos theta. Sine theta is x plus 2 over 4. And cos theta is this adjacent over 4. I'm just going to tack on a plus c. Okay, so that's our solution. In number 13, we should notice that the derivative of the denominator is 2x plus 10, and that is 2 times x plus 5, and we have an x plus 5 in the numerator. So this is a simple log. Log of the denominator. And since the derivative of the denominator is 2 times x plus 5, and here we only have x plus 5, we have a 1/2 in front. Number 14 is going to be a tangent trig substitution, because we have the 1 plus x squared here. So we're going to write x equal tan theta. The derivative is secant squared. Okay, so let's do our substitution. So here we have a tan cubed theta. And here we have 1 plus tan squared theta times secant squared theta d theta. Now 1 plus tan squared, that's equal to secant squared. So we have secant squared theta under the square root. Alright, so let's take that out of the square root. That gives us a secant theta. And then we have this secant squared theta next to the d theta. Alright, so what do we have? We have tan cubed theta, and we have secant cubed theta. So this fits into the category of odd exponent for tangent, and what we do in that case is we take off one secant theta tan theta and put it next to the d theta. So here we're left with tan squared, and here we have secant squared. This is going to be our derivative of secant. So we're going to put u equal to secant theta. Now tan squared, remember tan squared plus 1 is secant squared. So this is secant squared minus 1. So once we do our u substitution, we have u squared minus 1 and here we have a u squared, and here's our du. Okay, let's multiply through, and we have u to the 4th minus u squared du, and now power rule. And let's remember u was equal to secant theta, so this is secant theta to the 5th, and secant theta cubed. And now we want to convert back to x, so let's remember our original substitution. Okay, here's the original substitution, x equal tan theta. Okay, so I drew the little triangle, x equal tan theta. Okay, we had x equal tan theta, so that is opposite over adjacent is tan theta, and here's the hypotenuse, and we want secant. Secant is 1 over cosine, so it's going to be hypotenuse over adjacent. So secant is square root x squared plus 1, so let's just substitute that in. And there's our solution. And let's look at number 15. So number 15 has an even exponent for secant, so that fits into the category where we pull off a secant squared. And so here we're left with secant squared. This is derivative of tangent, so u is going to be tangent. Alright, and we're going to do a substitution for secant squared. Tan squared plus 1 is secant squared, so this is tan squared x plus 1. So changing over to u, we have u squared plus 1, u to the 4/3, du. Okay, multiply through, and this 2 is 6/3, so that would be 10/3. And now we just do a power rule. And add 1 over here. And now we just substitute back for u. We substitute back tangent x.